Ahoy, Captain, and welcome to this episode of How to Decarbonize Your Ship, the show in which we provide guidance on regulations and decarbonization measures. Today we're going to answer that particular question that's burning on the tip of your tongue. What would the impact be of an electrical short sea chemical tanker with regards to a FuelEU pool? No, not everybody's questioning itself that, but we had a look because an electric tanker or an electric vessel in general would yield the most benefits when it comes to FuelEU. So what we're going to look at is we're going to take an e-tanker, as we call it, and see how the overcompliance of electricity would affect a pool. And it would, as we have a look at the regulations, be the most overcompliant case you can ever make, because electricity is taken as zero emission within the FuelEU framework. And what we see is that we can compensate for about 69 ships in 2025. So one electrical tanker can compensate for 69 ships, meaning you don't have to pay a penalty for them, and only 2 ships in 2040. So the additional benefit really goes down fast. There is, of course, the matter of cost. We assume more or less a price parity of the fuel cost. So we're going to have a look at, well, overall roughly same cost. But as you can see, as we take MDO as a general fuel at 650 metric tons, we need a fuel cost or electricity cost of about 10 cents per kilo hours in order to have roughly the same overall costs. I'll show you all the details, but what this tells me is that we need some sort of power purchase agreement in order to get fuel cost parity. Of course, very tricky to do. 10 cents per kilowatt hour for your electricity or shore power electricity. That's a tricky one. And then finally, the tools that we're using is made by humans, or we sometimes make errors. Let us know if we do. And everything is also made with publicly available data, and you can calculate everything yourself. Well, without further ado, let's dive into the case. So the case itself will be the following. We're going to take a vessel, electric tanker with a compliance balance higher than zero. We're going to add additional vessels to them with compliance balances lower than zero. These can be added within the FuelEU regulatory framework. That is what's called a pool. And if the total balance of this pool is higher than zero or equal to zero, then we can call it a pool, a compliant pool where you don't have to pay penalty for the ships that have a compliance balance individually lower than zero. And we're going to take an electric tanker. What we'll do is we'll take a tanker consuming about 2,555 metric tons of MDO and then convert that energy into electricity, which with regards to FuelEU framework would yield the most amount of benefits, so that we can get an upper maximum of the total pool that we can create with one single tanker. So what we'll answer is, one electric ship can compensate for how many other vessels? Well, in 2025 that will be 69 fossil ships. So one electric tanker consuming 2,555 metric tons of MDO can compensate for 69 similar sized vessels in order to have a compliant pool. But of course the benefits up until 2050 will decrease every 5 years. So in 2030 it will only be 17 fossil ships, and in 2035 it will only be 6 fossil ships. And let me show you how that goes all the way until 2050. So until 2050, according to the current regulations, we still have a small amount of overcompliance generated with an electric ship, but as you can see, the benefits are, well, not negligible, but very, very low. So until 2035, there's a great amount of benefit using electric ships, or, well, very low carbon fuels in general. And then afterwards, we definitely have to do something to those individual ships. But this also gives you a very good argument to have a look at a single ship, convert it. I'm not saying go fully electrical, but to convert it, at least to have one ship in your pool, compensate for all the others until 2040. After 2040, you definitely have to take into account that every ship needs some sort of decarbonization measure in general. But until that time, you could make do with one or a few vessels that are providing you with FuelEU over compliance. Well, this is of course very generalized, but what if we have different fuels? What if we have different vessel sizes? How does it work all the way until 2050 with costs? We have made a tool, the FuelEU pool tool, in which you can customize your own case. So let's have a look and let me show you how that works for this particular case study. And here we have the pool tool. This is the premium tool on our member page, and if you watch the video or you are using the freemium tool, some features might not be available. In this premium tool we can take up to 20 ships. As you can see, we could go all the way up to 100, depends on what you want, but right now I'm going to go for 5 only because this analysis is already tricky enough as it is, and I just want to show you how it works and what the differences are, and we can always come back later. The ETS price, the EU ETS price, I'm just going to keep it at 65 metric tons, and what you see here, I've already preloaded the e-tanker with the amount of fuels per vessel, and what we do is we take a base case, an assumption on the type of fuel and the amount of fuel that you consume that leads to a certain amount of energy used per year, and we're going to convert that into any type of fuel that you want for that particular ship. So if we save this base case and continue, then you see here that there is a lot of information. Here we can see the current case, so you can see the fuel costs, EU ETS cost and FuelEU for that reporting year, and then for each ship. And we have our blender here, so we can go for 0% MDO and then we can go for 100% electric. And as you can see, overall costs 9 million, 8 million. We'll try to keep somewhat of a price parity between them. I'll come back to that later. Here we can save scenarios. So for this analysis, I'm going to take, let's see, 2025, one electric ship, 2035, one electric ship, and then I'm going to do, these two, and then I'm, well, you know what, we can always change. So I'm going to do 2050, one electric ship. Alright, so first 2025, one electric ship, there we go, lots of overbalance, different costs. Okay, so I'm gonna save this case and I'm gonna increase it to 2035, and as you can see I still have a remaining surplus. Oh, what I forget was one thing, going back to 2025, we want to distribute the total amount of surplus for the maximum, so that of course, there we go, we don't have any FuelEU costs less there, that's it. And then going back to removing the surplus, and then you see, so in this case, or not. Yeah, so it's still cheaper to simply pay the penalty in this case with respect to the fuel cost, etc. And that's how you can compare the things. Moving on to 2035, let's distribute all the surplus that we have. 2035, we still have remaining surplus, do we? No, not entirely. So this is the first year where we're going to start, as you can see, paying for a FuelEU penalty, as the total amount of surplus created by one electric ship in 2035 is not enough to balance out the other ships in this case. So I'm going to stick to that surplus, one electric, and I'm going to save that case, there we go. And then finally 2050, all the way up. Ooh, that's going to be expensive. I see what happened here. We don't have any surplus because the pool itself is not compliant. As you can see, we need the pool needs to have an over-compliance, or at least a balance of 0 or higher, otherwise we cannot balance them out. So saving this case, there we go. We now have a total of 32 million euros in costs. We cannot pull anything, so this is, I'm not really satisfied with this number, but let's first see how this looks with only MDO. Well, that's interesting, because if we use MDO only, it's still going to be more expensive. We pay less for fuel, EU ETS of course stays the same, but for FuelEU we pay a lot more penalties. So for this instance it would still be better to do fully electric. There we go. Now, because 2040 is such a tipping point for most vessels and FuelEU in general, let's have a closer look at 2040 and see if we can devise the most cost-effective fuel solution in order to comply with FuelEU and EU ETS combined with costs. So what we're going to do is we're going to do 2040 fossil only. Fossil, we're going to do 2040 electric, electric, see how many electric ships we need, and then we're gonna do 2040 biofuels, see if we can make a comparison there. So first, only fossils, we're gonna go to 2040, maybe we should go to 2039, there we go. Yes, I'm gonna go to 2039, so that as per 2040, things need to be different. So I'm gonna change this to 2039, and now we have 15 years to think of what we want, and we can maybe have one ship taking all the over-compliance, and then by 2040 have a transition of ships. So we have now the MDOs only, blah blah blah, so we do fossil safe scenario 1, there we go. So this is the total amount of cost in 2039, no remaining surplus, we distribute anything that we have, okay, 50 million. So 15 million is kind of like our base case. What happens if we do electric? Oh, okay, so 2039 too, that's already cheaper, 13 million. Okay, so this is already cheaper. So what would be the least amount of electricity? So we kind of need a lot of, well, if we're already at 70% electric, we can also do more. If we have fully electric here, will it become cheaper? Oh, here you can see an optimum roughly around, no, oh yeah, 20% safe. So here we have more or less a local optimum with using electric fuels at 12 million. So there is an over-compliance made by the pool itself. This could maybe be done with some sort of shore power and battery technology. This is fully electric. But then we have 5 ships, lowest cost would be 12 million. Now let's see how that would relate if we use biofuels. I'm going to use biodiesel, and of course I'll show you the pricing there as well. Ooh, if we don't do anything, yeah, we need at least more over compliance in order to compensate for FuelEU. Okay, so just one ship, biodiesel only. Let's see, save. Yeah, that's already more expensive than fossil only. And let's have a look at the fuel parameters. So you can change, of course, the fuel prices here, MDO in particular, and then you can see it directly influences everything. We're going to stick to 650. And here you can see all the different prices for biofuels. So biodiesel, there we go, 1300. Okay, that's not a bad price for like biodiesel of fame. HVO is maybe a bit low. So let's say it's we're in luck. 1000, and also let's see the total well-to-wake equivalent. Okay, this could be better. I've seen biofuels. This is quite some digits. I've seen biofuels with a lot lower total value of E. So I'm gonna override this, and we're gonna do cheap biofuels with a total E value of only 12. That means let's see, like used tires or cooking oil, the golden standard for biodiesel, and then let's have a look and see how that would impact the cost. So here we, yes. Oh, that's getting close to, I think. Yeah, that's getting close to the electrical case. So here you can see that a good biofuel for a very good price is almost the same impact as 10 cents electricity fully electric. Mind you, no additional CAPEX is taken into consideration for this particular exercise, so that is very hard to compare. But the further we go down into the future, the easier it is to only look at OPEX, because of course the CAPEX will be discounted. It might be cheaper for fully electric vessels, biofuels are different, everything. So the one thing we know are of course the OPEX, how much energy a vessel uses, the different types of fuel, etc. So then the analysis becomes well, different. And that is how an electrical tanker will impact your pool, and how the FuelEU pool tool can help you optimize FuelEU strategies, determine the most cost-effective scenario for your pool. Sign up today to use the premium tools, download them, and get support and all the solutions that you ever want at your fingertips. Thanks for watching the video and have a great day.